Welcome. We are here today to do some prediction interval calculations. This is the final exercise in section 10.3. So congratulations, you made it. Good job. All right, so with these prediction interval calculations, we are using, as you already know, we are using some data that we've already used in the past. We are using this data that's in this table, taken from exercise 16 in section 10.1 and exercise 16 in section 10.2. Additionally, in the blue box on the right-hand side, we have already calculated this regression equation in exercise 16 in section 10.2. Moreover, we are using our standard error of the estimate for this data, which we calculated in exercise 18 in section 10.3. Additionally, we've been given some more information. We have been told to find the prediction interval at 98% confidence, which is our alpha value there. And we've been told to find our prediction interval for an x value of 47. So that's what that red arrow is there. So using this information, let's review what the prediction interval calculation looks like. We know that the prediction interval calculation is, of course, an interval. So there will be a left endpoint and a right endpoint for this interval. The left endpoint calculation is as follows. It is our y prime minus the associated t value for our given alpha value and the degrees of freedom, multiplied by the standard error of the estimate, multiplied by a big square root of 1 plus 1 over n, where n is our sample size, plus n times x, which is our given x, minus x bar, where x bar is the mean of x or the average of x, squared, divided by n times the sum of x squared minus the square of the sum of x, There it is right there. And we'll just extend our square root and division symbols a little bit. And we know that's going to be less than y, which is the value we're concerned with, which is then less than y prime plus everything else. So plus everything that I will bracket in blue, plus all of this right here, right there. So the left endpoint and right endpoint calculations are very similar. The only difference is the left endpoint has a subtraction symbol and the right endpoint has an addition symbol. So before we get into filling in our table to the left, you might be asking yourself why we're filling in those specific values. So first and foremost, we can see right here, we can see that I've just underlined with green, that we need the sum of all of our x squared values. So because we need the sum of our x squared values, we obviously need to calculate our x squared values. Additionally, we need the sum of our x values. So we will need to calculate the sum of our x values. And calculating the sum of our x values will be helpful for calculating the average, because the average of all of the x values is simply the sum of all of the x values divided by the number of x values that exist. So let's just define that variable n. N is our sample size, otherwise known as how many x values there are. So our n in this case is 1, 2, 3, 4, 5. N equals 5. And as we know then, our degrees of freedom is going to be n minus 2 or 5 minus 2, otherwise known as 3. So our degrees of freedom are 3. So let's go ahead and start calculating our x squared values. So for example, 1,924 squared is going to give us 3701776. And we will go ahead and put that in its appropriate spot. And then similarly, 907 squared will give us 822,649. 1444 squared will give us 2088025. 1608 squared will give us 2585664. And then lastly, 661 squared will give us 436921. Perfect. So now let's calculate the sum of all of our x values, and I'll bracket that in red, bracket it in, or box it in red rather. So let's calculate the sum of all of our x values. So if we sum all of those numbers, we get a value of 6,545. 6,545. And we'll drag that over to its appropriate box. And then similarly, if we sum all of our x squared values, which I will box in blue right here. I know I'm overlapping some of those numbers. Hopefully you've already written them down. So if we sum all of those numbers, we get a value of 9635035. Perfect. We're almost there, so all we need to do now is run a few more calculations. So as I stated earlier, we're going to want to calculate our average of the x values, so our x bar. So calculating our x bar, we're going to look at the sum of all of our x's, or 6,545. 6,545 right here. And I'll point to it with an arrow so we know where we're getting that from. That's right here. Our sum of all of our x values divided by our how many x values we have, or n in this case, which is 5, which gives us an x bar value of 1,309. 1,309. Additionally, we know that we want a y prime value. And you might be asking, which y prime value do we want to work with? That'd be a great question. We want the y prime value that is associated with this x value that we're given, the x value of 47 in this instance. So if we plug in 47, to our x in our regression equation, we get a y prime value equal to about 1,410.85. 1,410.85. Perfect. And then lastly, we want to look at any general or generic t table. We want to look at any generic t table for our associated t value for our confidence level of 98%, and a degree of freedom of 3. And we find that our associated t value is going to equal approximately 4.541. 541. Wonderful. Now we can go ahead and start directly calculating our prediction interval. So let's start with the left endpoint, and I'll type it out as much as I can so it's easier for you to read. So we know that we want our y prime value, so 1,410.85 minus our t value, which is 4.541, multiplied by our standard error of the estimate, which is 213.10. And let me drag that over, enlarge it a little bit, and bring out my, my utensil. And so this is going to be multiplied by our big square root of 1 plus 1 over n. And 1 over n is going to be 1/5 in this scenario, plus n, or 5. 5 times our x value. Our x value in this case is 47. 47 minus our average of the x's, our x bar, which is 1,309. 1,309. Right there. Squared. Divided by our n, which is 5. Once again, 5. times the sum of all of our x squared, which in this case is going to be 9635035. So 9635035 minus the square of the sum of our x's. So the sum of our x's is going to be 6,545. So minus 6,545 squared. 6,545 squared. And we'll just go ahead and extend our division symbol and extend our square root. And we know this is less than our y, which will be less than the right endpoint, which is a very similar calculation. So we know that's going to be our y prime value of 1,410.85 plus, this is the one key difference, plus our t value of 4.541 times our standard error of the estimate, which is 213.10. And for the sake of time, I will simply put another blue bracket to indicate the fact that we are multiplying all of this underneath the blue bracket right there. We're going to multiply that simply for the sake of time. And then plugging all of that into a calculator, we find that our prediction interval is 280.697, which is less than y, which is less than 2,540, 2,540.621. 621. Now, of course, with rounding, there may be some variation in these answers, but if your answer looks approximately similar to what I've got, then you should be good and you should be set. Finally, before we conclude today's video, we just want to explain what this means in context. We know then that we are 98% confident that for this data and for an x value of 47, the true observed y value exists in this interval. So I hope this helps, and keep at the great work.